Hello students, now we come to lecture 2 of unit 1, description and construction details of IC engines. Aluminium and its alloys are mainly used for casting of engine blocks, cylinder heads and manifolds, both the exhaust and inlet manifold. Let us look at the construction details. This is a typical naturally aspirated single cylinder petrol engine. Inlet valve, exhaust valve, the valve springs which operate the valves. Inlet port, inlet valve is above the inlet port and the exhaust valve is above the exhaust port. This is the cylinder head. This is the engine block. Now presently the piston, this is the piston, it's at the top dead center. The bottom dead center when it goes down, the bottom dead center, as you know, the distance between the TDC and VDC is the displacement volume. You must have read in the first or second semester. These shown are the cooling fins which cool the engine. Now the piston is connected to the crankshaft by means of a connecting rod. This is the small end of the connecting rod. This is the big end. The small end is connected through a pin called the gudgeon pin or wrist pin. In USA they call it wrist pin. The big end is connected to the crank pin which is integral to the crankshaft. This is the crank which is generally filled with oil. Now we come to the working of a 4-stroke diesel and petrol engine, and thereafter we will also briefly touch upon the lately developed overhead camshaft. There are 4 strokes in an engine, internal combustion engine: suction, compression, expansion and exhaust. You are probably conversant with it. You must have read in basic mechanical engineering in the first or second semester. Now in the suction stroke, the piston will move from the TDC to the VDC 180 degrees. Let's say this is 0 degrees up to 180 degrees. By moving downwards, it will create a suction and the pressure will fall to about 30 kilopascals or 0.3 bar below atmospheric pressure. However, this figure may vary according to the speed or load that the engine is carrying. So, with the suction created, the Y below atmospheric, the entrance of the intake is restricted. Therefore, to get as much charge into the cylinder as possible, this suction needs to fall below atmospheric pressure. Then only you will get a substantial amount of fuel air mixture into the piston. Now we are discussing the 4-stroke petrol engine. This figure is common to petrol and diesel. Only difference is that in place of the spark plug, it's a fuel injector. So TDC to BDC 0 to 180 degrees called the suction stroke. Thereafter from 180 to 360 the piston will start moving from the BDC to the TDC. Thereafter, as it reaches the TDC, or just before that, the spark plug gives a spark. An explosion takes place and the combustible products burn rapidly. The temperature and pressure rise considerably, which force the piston downwards. This is called the expansion stroke or the power stroke. Now in the induction, the inlet valve was open, exhaust valve was closed. And in the compression, naturally both the valves, inlet and exhaust, would have to be closed. During compression, the cylinder pressure may rise from 800 to 1300 kilopascals, and after ignition, the pressure may reach even up to 6000 kilopascals. In the power stroke or expansion stroke, the cylinder pressure falls to around 400 kilopascals. That is from this point again to this point, after 180 to 270 degrees. The fourth stroke is the exhaust stroke. In this, the inlet valve would be closed and the exhaust valve would be open so as to expel the combusted products. This was the working of a four-stroke IC internal combustion petrol engine. Now, for a diesel engine, as I mentioned earlier, instead of the spark plug, there will be a fuel injector. The strokes are basically all four same strokes. The little difference is that after the suction, in the compression stroke, the air, here there is no mixture, it's only air in diesel. Diesel is sprayed subsequently. Let's say the air is compressed to about 22:1. 22 means the original volume, if it was 22, it is compressed to 1. And the compression ratio would be of the order of 22:1. A pressure of about 3500 kilopascals is achieved and the temperature rises to about 600 degrees centigrade. Remember that the ignition temperature of diesel is 400 degrees centigrade. So once this temperature is 600 is more than that, pressure is also increased. So once at this point, when just before it reaches the BDC, when the piston reaches the BDC, the fuel injector sprays the diesel at high pressure. This combustion takes place and the force of combustion pushes the piston down, and this is nothing but the working or the expansion stroke. Here, of course, both the valves would be closed. Now in combustion, there are 4 stages of combustion in a diesel engine, unlike that of a petrol engine. The first is a delay period. In the delay period, the liquid fuel turns into vapor. The second stage, all these stages, there are 4 stages, is happening at the time from the start of combustion to the end of combustion. There is an uncontrolled burning because of the high temperature and pressure. It's uncontrolled. Thereafter, there is a controlled burning because the diesel is being sprayed very systematically at a high pressure, uniformly, and that's when the burning gets controlled. The fourth stage of combustion in a diesel engine is called afterburning, and this happens once the injector stops spraying, the remaining fuel burns off. The salient features are: the power in a diesel engine is directly proportional to the fuel injected. If you increase the fuel, the engine speed will increase. Engine speed increases means the torque will increase. The fuel injection can be limited by the means of a governor. You must have heard in school buses, college buses, governor has been fitted. We hear that. And it is generally set, the governor is set to provide an enrichment of 10:1 by weight. There is 10 parts of air and 1 part of diesel.